equations is the name of section 4.3. Is it just me, or is the writing clearer now on these worksheets? I think at the last time I updated the software, I think they've improved this. It looks so much clearer. I love it. All right, so we got a few terms here to learn first, and then we'll talk about linear equations. First of all, people often get expressions and equations mixed up. An expression is a collection of numbers, variables, and operation signs. So you know what numbers are. You know what variables are, right? Letters or symbols that represent unknowns. And operation signs are like plus signs or minus signs or multiplication signs or divided signs or square root signs or squared or cubed or all that kind of stuff. So for example, an example of an expression would be something like, well, how about 5? There you go, it's a number. That's an expression. How about 7x? It's a number with a variable. What's this number doing to the variable? Multiplying. That means 7 times x. How about 2y squared minus 4x? Yeah, that's an expression. And one more, how about square root of m plus 2? These are all examples of expressions. Now, what do those things not have? They do not have an equal sign. That's what makes an equation an equation. It's a statement that two expressions are equal. So you're going to see an equal sign in an equation. So that could be something like, so basically what you do is you take two of the expressions, any two expressions, and you make them equal to each other, and you've got an equation. So something like 3x equals 2. All that is saying that we have two expressions, one's 3x and one's 2, and they have equal value to each other. They're equal to each other. So that's one. How about y equals 7? That's an equation. And let's do a complicated looking one. How about x plus 7 all squared equals the square root of x? Notice that you can have the same letter showing up more than once in the same equation. Okay, linear equations. So over the next few years of math, you're going to learn about linear equations, quadratic equations, cubic equations, quartic equations, all sorts of different equations. We're going to start with the most basic, which are linear equations. And a linear equation is any equation of the form ax plus by equals c, where a, b, and c are all numbers. So you can put any number you want into the a and the b and the c here, and you will have a linear equation. For example, if we had something like 5x plus 3y equals 7. So you got the x and y there, and your a is 5, your b is 3, and your c is 7. I've just stuck some numbers in for the a, b, and c. Okay, pretty straightforward. How about this one? How about if I had negative 2x equals 9? Now at first it looks like this doesn't meet the criteria because we need to have an a, a b, and a c value. We've got an a, which is negative 2, and there's the x. We got a c, which is 9, but what happened to this here? There's no y. Does that mean this is not a linear equation? This is still a linear equation. Can you figure out what b must be in this case? Remember, b can be any number. What would make the y disappear entirely? If b was 0, right? If b was 0, another way we could write this is negative 2x, just like here, plus 0y equals 9. Well, if I have no y's, that means there is nothing here. So why even write it? In which case you'd just be left with this. Okay, don't worry about that too much about that right now, but what our task is today is to learn how to graph linear equations. And we're going to learn how to graph some which are exactly in this form here, this ax plus by equals c. You can see it again right here, ax plus by equals c. So that's the first thing we'll do. And then there's another form that we want to learn how to graph as well. They're very similar to each other. Alright, so before we learn how to graph these two things, we're going to graph 3x minus y equals 9, and we're also going to graph 4x plus 1 half y equals 2. So, before we do this, don't write this on your graph because you'll need this graph for something else, but I just want to ask you something. This axis right here that runs on the horizon, the horizontal, what is that axis? That's the x-axis. Now, any point on that axis, let's name a couple points. What's this point? If you name that point, what is it? It's 4, 0. How about this point? That's negative 2, 0. And one more, how about this one? That's negative 8, 0. What do all the points have in common on this line here? They all have the same second number, which is the y value. They all have the same y value, which is 0. all these points here are called x-intercepts. And the reason they're called x-intercepts is because they intercept or touch or cross the x-axis. So what's true about all x-intercepts is they have a y value of 0. Maybe I should actually write that down. I'll put it over here. All x-intercepts have a y value of 0. So if we wanted to know where the x-intercept is in this equation right here, what we could do is substitute into y 0, because we know that the x-intercept always has a y value of 0. So that's going to be the first step. You're going to find the x-intercept by setting y equals 0. Okay, now something very similar to that. Let's take a look at this line here, this axis right here. What's that axis called? That is the y-axis. Let's look at some points on this axis. Like this point here. What's the name of that point? It's not 8, 0, it's 0, 8. How about this point right here? That's 0, 1. And this point here? That's 0, negative 5. So what's true? These are called y-intercepts, right? Same reason. Why are they called y-intercepts? Because they intercept or touch or cross the y-axis. So what's true about every y-intercept is they have an x value of 0. Let me write that down as well. So your second step is going to be to find the y-intercept by setting x equals 0. So let's start by doing that. Let's first of all clear this up here. And I'm going to try to graph 3x minus y equals 9. So I'm going to make a little table of values for myself here, and I'm actually only going to need 3 points. So it doesn't have to be that big. And the first point we're going to find is we're going to find the x-intercept. In other words, we're going to set y equals 0, because we know for every x-intercept, y equals 0. So let's try that. If I put y equals 0, so I have a 0 here. Well, now what I have is 3x, take away nothing, so that's not even really there. 3x equals 9. Oh, well, we can solve that. If 3x equals 9, divide both sides by 3, right? Divide by 3, divide by 3. You get x equals 3. Oh, okay, so the x-intercept is 3, 0. So I can graph that. 3, 0 is right there. Okay, now we do the same sort of thing, but this time we're going to set x to 0, and we're going to find the y-intercept. So let's do that. We put 0 in here. So that means 3 times 0. It doesn't mean 30. It means 3 times 0, which is 0. And be careful here. What we still have is negative y, or minus y, but think of it as negative. So negative y equals 9. What happened to this bit here? It's gone, because 3 times 0 is 0. It's not there anymore. So negative y equals 9. If negative y equals 9, what does y equal? Y equals negative 9. If that confuses you, divide both sides by negative 1, because there's really like a negative 1 out front here. So if you divide both sides by negative 1, you'll get y on this side, and 9 divided by negative 1 is negative 9. So you get negative 9 on this side. Okay, there's our next point. 0, negative 9. That's way down here. Alright, let's see what the next step is, because we still have 2 more steps to go. The next step is to find a third point. Well, how do I do that? Well, one thing you can do is you can take a look at the pattern so far. You see how it's gone x equals 3, and then x equals 0, and then you could go down, since it went down 3 here, you go down another 3. But the problem with doing that is this will also go down the same amount. So if this went down by negative 9, you'll go down another negative 9. It's going to be too small. Okay, look, what if we looked in the other direction? We've gone from 0 to 3. What would be the next point up? How about 6? Let's see if that works. So if we put 6 in here, you'd have 3 times 6, which is 18, take away something, equals 9. Now just by looking at that and thinking about it, you can probably figure out that the answer is 9. If you can't figure that out, then what you could do is you could subtract 18 from both sides. You get negative y equals negative 9. Then divide both sides by negative 1. You get y equals 9. Yep, we got it right. Now, here's another reason you know it's probably right. Because if you look again, it goes 0, 3, 6, going up by 3 each time, and negative 9, 0, 9, going up by 9 each time. So I'm feeling pretty confident about this. Let's graph this point. 6, 9. Now, the last point, and this is when you'll become even more confident in your answer, you should be able to plot the points and draw a straight line. This is why it's called a linear line equation, because you should always get a straight line. So I will now draw a line with my 3 points, and they should line up perfectly. Let's see if it works. Absolutely. It goes through all 3. And then what I do is I put an arrowhead on each side. So I need to extend this one a little bit. and put an arrow on it. Okay, if you don't put arrowheads on it, it means it stops, and it doesn't stop. This goes on forever. There's an infinite number of points that could be fit in here, right? Each point on this graph has a different x and y value. There's an infinite number of points that work if you plug their x and y values into this equation here, but they all end up on this line, which is pretty cool. Now, some people might say, why did you bother with the third point? You could have done it after 2 points. Well, the reason for that is because the third point really helps check your work. Say that you did the first 2 points, the same ones that we did, which were these two down here, and then your third point was right here. You did something wrong, because either the graph would go like this, or maybe the graph goes like this, or is there another possibility? I think that's it. So by doing the third point, it really does help to make sure you didn't make any mistakes. Okay, let's try another one. So again, what we're going to do is we are going to make a little table of values. And first of all, we'll put 0 in for y, because we want to get the x-intercept. Well, if I put 0 in here, this is gone, because 1/2 times 0 is nothing. So I'm just left with 4x equals 2. How do I solve that? I divide by 4 and divide by 4. That means x equals 2 over 4. If you put that in lowest terms, 1/2. So one point is 1/2, comma 0. That's fine, we can graph that. 1/2, comma 0. Doesn't have to be a whole number. It's nice when it is. A pretty point, I call it. Doesn't have to be a pretty point. It can be a not so pretty point. Okay, next thing we do is you put 0 into x. So you put 0 here. 4 times 0 is 0. This is gone. You're left with 1/2 y equals 2. How do you solve that? Well, there's two ways you could solve it. You could multiply both sides by 2, because when you multiply this side by 2, the 2's cancel, and multiply this side by 2, you get y equals 4. I like that method best. If you don't like that, the other way you could do it is say, well, this 1/2 is multiplying by y, so I could divide by 1/2 and divide by 1/2. And that's a little tricky, 2 divided by 1/2. What you'd have to do is you'd have to make it 2 over 1, and you do the reciprocal when you divide fractions, right? So it would actually be 2 over 1. You'd end up with 4 over 1. Either way, you get 4. It doesn't matter which way you do it. Personally, I think it's a little easier just to do that multiplication step, and you'll get 4. Okay, so 0, 4 is here. Now again, we need one more point. Okay, again, if I look at the difference here, it goes 1/2, 0. Maybe you want to put negative 1/2 here, or maybe you want to go up another half and go to 1. Or, I mean, you don't have to do this. I just find this is a good way to get nice points. I also see 0, 4, so maybe I want to put 8 here, or 4, 0, maybe I put negative 4. I'm just looking at patterns, right? I don't know. I'm going to go with 0, 4, 8. I'm going to put 8 in for y. So right here, I'm putting 8. So the first thing we have to do is we have to go 1/2 times 8, which is the same as 1/2 of 8. What's half of 8? 4. So we get 4x plus 4 equals 2. You know how to solve that. Subtract 4, subtract 4. We get 4x equals negative 2. Divide by 4, divide by 4. You get x equals negative 2 over 4, or negative 1/2. Feel confident about that answer? I do. Look at 0, 4, 8 is a pattern. 1/2, 0, negative 1/2 is a pattern. If you get that pattern on both sides, that's a linear equation. So let's graph that last point. It's at negative 1/2 and 8, way up here. It's a very steep graph. So again, I'll take my line, and it should be in a straight line. I think you can tell it already is. I'll put arrows on both ends. So I'll just extend that a tiny bit so I can put an arrowhead on it, and I'm done. There we go. We've graphed both of those linear equations. Okay, the next one's very similar. This is actually the most common, probably, way we show lines. We do it in y equals mx plus b form. We'll talk lots about that at a later time, and you're going to find a really fast way to graph these. For today, we're going to give you a slower way to graph them. That's fine. It's good to learn this first, and then we'll learn the faster way. This is called slope-intercept form. But we're not even going to talk about what slope is and intercept and stuff today. What we're going to do to graph these ones is we're going to find 3 different values of x that are divisible by the denominator of m. If you don't understand what I mean, just wait a second and I'll show you. Then we're going to solve for y in each case, and then we're going to graph the points and draw a straight line. Basically, all we're going to do is make a table of values and we find 3 points. So let's go for it. Again, just like before, you've got a y and an x in this. There it is, a y and an x. And the m and the b can be any numbers. The reason it's m, well, we'll talk about that at a later time. So I will need an x and a y. So what we want to do is pick values for x. It's going to be easier if we use the input value of x. So what would be a really, really easy value to pick for x? How about 0? If we put 0 in there, you get negative 2 times 0, which is 0, plus 4. That's 4. What else do you want to put in there? Well, sometimes I like putting one positive number and one negative number. Why don't we put 2 and negative 2, or 1 and negative 1, or negative 1 and 3, or something. You don't have to put negative numbers. You can put 2 and 3, or 1 and 2, or 2 and 5, whatever you want. But I'll go with 2 and negative 2. So if I put 2 in there, negative 2 times 2 is negative 4, and then I add 4, and I get 0. Okay, if I put negative 2 in there, negative 2 times negative 2 is 4, and 4 plus 4 is 8. Does this look like a linear equation? It might not at first, but it's because I haven't written them in the right order. Right? The smallest point here is negative 2, then 0, then 2. We go up by 2, up by 2. If I look in the same order, I go 8, 4, 0, down by 4, down by 4. Yeah, this is a linear equation. So let's graph this. 0, 4 is the first point. That's right here. 2, 0 is the second point, right there. And negative 2, 8 is the third point, right there. Great. Straight line again. We're doing a great job here. So there you go. Now notice those weren't the only 3 points you could have picked, right? You could have picked any of the points along this line here. And that's why I put the arrows on the end to show that, yeah, I picked 3 points that worked, but those aren't the only 3 points that work. There's an infinite number of them that goes on and on forever in both directions. Okay, last one of the graphing. We're going to do an x and a y. Now, when we pick our x's here, this is why up above I said, pick a number that is divisible by the denominator of m. So there was no denominator here, or at least none you can see. It's a denominator of 1. But here we have a denominator of 4. Don't pick a number like 5, because then you have to multiply 3/4 times 5 and you get ugly fractions. But if you multiply by a number that's divisible by 4, you're just going to just cancel out and you're going to only have whole numbers, and we like that. What would be the easiest number to pick? Well, how about 4? That would be great. Actually, you probably picked a different number as your easiest one. You're smarter than me. What would be an even easier number than 4? 0. That would cancel it out altogether. And what do you want to pick next? You want to pick negative 4 or 8 or something like that? Let's go with negative 4. I like using my negative number. Alright, 4. I put 4 in here. So I get 3/4 times 4. I'm going to write that up here. 3/4 times 4, which is the same as 4 over 1. Hey, do you know how to simplify before you multiply? Cancel, cancel. Those become 1s. You're left with 3 over 1, or just 3. So 3/4 times 4 is 3. Take away 6 is negative 3. This one's even easier. 3/4 times 0 is 0. Take away 6 is negative 6. And if we put negative 4 in here, so it'd be exactly the same. 3/4 times 4, but it'd be negative 4. So when you cancel out, you'd be left with negative 1 here. So you'd have 3 times negative 1 is negative 3. And then you take away the 6, you'd get negative 9. Does it look linear? Absolutely. 4, 0, negative 4, it goes down by 4. Negative 3, negative 6, negative 9 goes down by 3. We're ready to graph. 4, negative 3 is here. 0, negative 6 is here. And negative 4, negative 9 is here. Draw a line through them, and we will be finished our graphing. Okay? Remember, 3 points is very useful to make sure that you didn't make any mistakes. Next, determine whether the given ordered pair is a solution to the equation. So remember, we said when you graph these things, there's an infinite number of points that work, all the points on the line here. But if I don't graph it, how do I know whether 4, negative 2 is one of those points on the line? How do we know whether it works? Well, you substitute the point in, don't you? What's the first value? Is that an x or a y? X. Second point's always y. Remember, alphabetical order, x, y. So all you do is plug those points in. 5 times x, which is 4, minus 3 times y, which is negative 2, equals 26. Or is it? We don't know, so I'm going to put a question mark on top. It might be 26, we're not sure. 5 times 4 is 20. Now, you can either think of this as negative 3 times negative 2, which is positive 6. That's the way I like to do it. But I find a lot of people go, take away. 3 times negative 2 is negative 6, and then that becomes positive. So whichever way you like. But I'm going to show you the other way again, because that's the way I like to do it. I'd say negative 3 times negative 2 is positive 6. Equals, or does it, 26. Is this true? Yeah, it is true. Yes. So absolutely, if we were to graph this, this point would be on the line. And the other way you can think of it is, this point solves this equation. If you plug these in, it works. Does this point work when you plug it into here? Well, let's find out. Let's plug in those points. So you get, I know it's a weird point, 2/5, but that does exist, right? 2/5 comma 7. Let's see where 2/5 comma 7 would be. 2/5 comma 7 would be, well, 2/5 is less than 1. It's not quite halfway. It'd be about there. And then 7. So it'd be right around there. There is a point, 2/5 7, isn't there? Maybe it works in this case. Let's see. As I said, not every solution is a pretty point, so it could actually work. So let's plug stuff in. Y, what's the y value? The y value is actually 7. It's the second number, right? 7 equals 10 times x, which is 2/5, and then we're going to take away 11. Got to do the multiplying first. Let's think of it as 10 over 1, and why don't we do some simplifying? Some ninja slicing, as my grade 8s call it. That's a 2, and that's a 1. So what we have is, oh, question mark. We don't know if it's equal. 7 equals, maybe, 2 times 2 is 4, and take away 11. 7 equals negative 7? No way. 7 doesn't equal negative 7. No. This point is not on that line. This point is not a solution to this equation right here. Okay, this is the start of solving equations. It's a very, very important topic. So we're going to spend quite a bit of time working on this over the next probably month or so.